Hello, good afternoon, good morning, and welcome to today's webinar entitled Enhanced Innovative Technologies for a Global Production of Sustainable Aviation Fuels. Today's webinar is jointly organized by IEA Bioenergy TCP Task 39 and ICARUS project. As usual, I remind you that you have the possibility to drop questions by using the Q&A tab that you can find at the bottom of your screen. The speakers will reply to your questions at the end of all presentations during Q&A sessions. Please do only use the Q&A tab to ask questions and do not use the chat. The chat is just for greetings and to say hello to our speakers. The recording of this webinar as well as the presentations will be available from tomorrow on IEA Bioenergy website and on the ICARUS project website. That's all for my side. So I'll give the floor to the moderator of the webinar, Franziska Müller-Lange, and enjoy the webinar. Thank you.
Yes, Kiana, thanks a lot for this nice introduction and welcome to everybody also from my side. Good morning, good afternoon, good evening. It's really nice to have so much participants here for our workshop that is on enhanced innovative technologies for the SAF production globally. And just short introduce myself, Franziska Müller-Lange with the German Biomass Research Center. There I'm responsible for the Department of Biorefineries. We are dealing with processes on bio-based products and renewable fuels for a very long time. And I have the honor to be part of the IEA Bioenergy Task 39 as the German national team leader, and at the same time be a partner of the ICARUS project, which will be introduced soon also in our webinar today. Yeah, ladies and gentlemen, I guess all of you are aware that we need at least, and these are the best case scenario, 10 times more renewable fuels until 2050. And reflecting that, we have just 25 years more to set this minimum of about 50 exajoule of renewable fuels starting from now, where we have roughly 4.5 exajoule. And the low-hanging fruits from the technology side are almost picked up. So we have to go for technologies that allow us to have transport fuels with standardized specifications that we need, and at the same time, of course, to fulfill sustainability criteria. So it's the task of all of us, especially also for SAF, sustainable aviation fuels for the future, that we have to work on technologies that are usually more complex, more diversified with regard to biomasses to be used on the one hand side, but on the other hand side to set the right frame conditions also with regard to make sure that standardized and renewable fuels and sustainable fuels are used. At the moment, the SAF market is that way that we have roughly 2 million tons of capacity produced worldwide. And just to give you perspective, at least in the European Union with the refuel aviation that is in place, we need 70 million tons by 2050. So this is a factor of more than 20 for the next 25 years. So the task is really huge, and I'm quite happy to have today quite nice colleagues with us. Mercini Christou is from CRES in Athens. She's at the same time coordinator for the ICARUS project, and the ICARUS project is dealing with innovative technologies for SAF, in addition to HEFA SPK, which is the most common fuel for today. She will give an insight. Then we have Kyriakos Maniatis with us. He is now an independent consultant and also an ICARUS partner. And as I mentioned, it's a task of all of us, and he will provide us how we can go this joint journey for the Europeans and also the mission innovation countries. Both are quite well connected, not just within IEA Bioenergy, but also within the ICARUS project. And last but not least, José Mucias from the Netherlands. She is also part of the IEA Bioenergy Task 39, and she will give us an insight on the improvement opportunities for the frame conditions for low GHG emission and sustainable biofuels. Happy to have all of us with us here, and I would like to hand over to Mussini to give her first presentation. Thank you.
Thank you, dear Francisca. I will try to share my screen. Please let me know if it is visible.
Yes.
And in, let me try the presentation mode. All right. But it started not from the beginning. So, good morning, good evening to all. Many thanks, first of all, to the organizer, to the IEA Bioenergy Task 39 for inviting ICARUS to this really very interesting webinar. I'm happy to present, and of course, many thanks to ETA Florence that always supports such exciting, such fruitful webinars. So I will try to present you today ICARUS project. It is an international cooperation of sustainable aviation biofuels. My name is Mussini Christou. I'm leading the biomass department of CRES. I'm an agronomist by expertise, so I will try to pass you as best as I can what we are planning to do in this project. So I will give you a few words about what the project is about, its objectives, innovations that we are now started to test, and some first results and further reading. So what is ICARUS? ICARUS, it is a European funded project in the framework of the Horizon Europe program. It started in October 2023, so we are now entering our second year of activities. It will last for 3 years, and our budget is a little bit higher than 3 million euros. We have 14 participants from Europe, plus another 6 associated partners from Switzerland, Canada, 2 partners from India, and another 2 partners from Brazil, because that specific project needed an international practice for scaling up sustainable biofuels. And we are really very happy to have them on board as associated partners working with us, although they are not funded by the European Committee. Apart from the associated partners, we have the honor and the pleasure to establish an external executive advisory board. And there we have members from NREL, Dr. Robert Baldwin and Dr. Marisol Berti from the North Dakota State University. They are both collaborating as members of the advisory board in providing us insights and their expertise in technical issues in the syngas, for instance, value chain and in the feedstock. In addition, we have Professor Glaucia Sousa from FAPESP in Brazil and Thomas Ekborn from the Swedish Bioenergy Association. They are both representing the IEA Bioenergy, and they are going to help us with the capacity building globally. We are very happy to have them on board right from the beginning. And then we have Marco Bouffy from JRC and Themistoklis Neokosmidis from Concave to help us out with the sustainability assessments and the coordination with the oil sector that is required by our project. The objectives now of ICARUS is to develop the best practices and the best concepts regarding 3 very distinctive and most promising pathways for SAF production, both in Europe and in the mission innovation countries that we have included. And as I said before, considering, of course, that those pathways are promising regarding their technical feasibility, the economic viability, and their environmental impacts. So the first pathway is the biocrude oils to SAF. There we have the collaboration only from European partners. The second pathway is from alcohols, isobutanol specifically to SAF. where we have the collaboration of both European, Brazilian, and Indian partners. And the third pathway, it is syngas to SAF, where almost all associated partners are involved, plus members of our advisory board. In addition to that, we are also carrying out research on the feedstock itself, parallelly, I can say, to those three value chains. And then we have the collaboration of Indian partners and a partner from our advisory board. Now, the specific objectives is, first of all, to see what are the framework conditions for SAF developments in Europe and mission innovation countries, where we are, so that we will identify how to scale up the most promising technologies that we have selected. And then, of course, to improve this scaling up, the third objective is to enhance the overall cost effectiveness and sustainability of biofuels of SAF from those three separated value chains, and develop best practices and concepts again along this entire three value chains. We also want to set up guidelines for scaling up and synergies between the private industry and the scientific community, both at European and global level. Finally, of course, to effectively disseminate and exploit our results. And this is the reason we are very, very happy to be here and present you the project. So the value chain, number one, what are the technical novelties? As I said, the value chain number one is the biocrude oils to SAF. And there the objective is to evaluate and analyze innovative and promising catalytic hydrotreatment approaches for biocrudes produced through the hydrothermal liquefaction. As you see in the small picture below, there are innovations in two of the whole stages of the value chain. And those innovations deal with improvements of feedstock pretreatment and HTL processing to reduce the nitrogen in the biocrude prior to hydrotreating. And then second novelty is to create an innovative catalyst bed with blends of strategic catalysts to simplify the hydrotreatment process by decreasing the steps, the energy to hydrogen consumption and material supply, that is after the hydrothermal liquefaction stage. The second value chain is about alcohols to SAF. And here the objective is to explore various methods for converting alcohols, such as ethanol and methanol, into sustainable aviation fuels, taking into account technological advancement and economic consideration. Again, in the scheme below, innovations will not come in all the steps of the value chain, but in one specifically, mainly to optimize the yeast for the direct conversion of cellulose and C5 to C6 sugars into isobutanol. And it will be done with the engineering of secretion of cellulosic enzymes in second generation isobutanol yeast in order to minimize the need for an expensive cocktail of enzymes and, of course, lower the enzyme costs in the biomass saccharification process. The third value chain deals with syngas to SAF. And here the objective is to assess the current and emerging technologies for syngas production from gasification and then gas conditioning, upgrading, and analyzing the relevant policy developments and regulatory frameworks. Again, technical novelty relies to a specific stage of the whole value chain, that is in the Fischer-Tropsch synthesis, and the innovation lies in designing and testing a new Fischer-Tropsch catalyst in order to produce only liquid bioproducts at the end and allow smaller sized plants fitting much better to the local availability of biomass. The utmost, of course, objective is to significantly reduce the capex and hence to improve the economic viability of the whole pathway. Apart from these value chains, in parallel, I can say, of the value chains, we are carrying out novelties in the feedstock part separately. And here the objective is to assure sustainable, affordable, and diversified biomass feedstocks. The innovation lies in the cropping systems that we are using. So we will have biomass sorghum cropped with legumes and cover crops in a mixed cropping system. Here the innovation, the objective is to manage the species and the combination of the feedstock so as to somehow regulate the lignocellulosic, the oil, and the mineral composition of the blended feedstocks, not only working on one feedstock, but in a blended feedstock, in a mixture of feedstocks. And those mixed cropping systems will be integrated with crop rotations that aim to increase the biomass availability by 3, even 4 times, and thus contributing to the better use of the land resources. And all this research is, of course, based in previous proposals that we have, previous projects that we have tested them. Last but not least is we are carrying out innovation in the sustainability analysis systems. And here the innovation lies in establishing a novel framework of sustainability analysis that will cover the whole value chain for SAF production technologies that are still at pre-commercial stage, so as to facilitate the scaling up, including the innovations related to the production, to the technologies. As I said before, we just started. It's only 1 year, so as you understand, we do not have much results to present apart from the framework conditions for feedstocks and for technologies. Being an agriculture engineer, I feel more comfortable in presenting you the biomass that we have found that is available for SAF production. That mainly consists of agricultural residues. We have analyzed the availability of straw, for instance. We have seen that there are considerable amounts available. However, the challenge lies in the competition with other markets and the feed market. Here, the data rely only to the straw that is not used for feed. And we have identified that around 68 million tons per year could be available for SAF production. Below, you can see a table of the fuel characteristics of this resource. Then is the planning. It is an underdeveloped raw material, I can say. It is still challenging, though. This is why it has not been used at a large commercial scale so far. And the innovation lie in improving the logistics, mainly how to collect the harvestable material from the fields and then transport it, store it, and so on until the final use. We have identified grapes, residues from grapes, olives, and then citrus trees, apple trees, stone fruits trees, and so on. Main contributors are France, Greece, Italy, Poland, Portugal, Romania, and Spain. Here below, we have also identified their fuel characteristics. The third really important raw material that can be used for SAF production is the municipal solid wastes. We have identified something like 55 million tons per year available for use for sustainable aviation fuels. They bear a high environmental burden, so it will be really profitably used for SAF. And we have also identified an increasing trend in the municipal solid waste generation, which justifies the importance of this source for these technologies. And finally, the energy crops, where our main research lies. We have identified oil crops such as carinata, camelina, castor, Solaris Energy Tobacco, Saliconia, Pennycress, Jatropha, sugar and starch crops like sweet sorghum, and lignocellulosic crops like the perennial grasses, switchgrass, miscanthus, giant reed, and reed canary grass. All of those are tested in many trials in the past, so we are now trying to fit them in those mixed cropping system I mentioned before. They are still at very low TRL level, and we are planning to really use this research in order to promote, to progress with the scaling up of these crops. And these are the cropping systems that I mentioned. There's a variety of cropping systems, starting from the left-hand side, the monoculture that is avoided, that has to be avoided. Then we go to polyculture, and we have sequential cropping, intercropping, and a number of systems below. We have data from the past regarding the rotations of lignocellulosic crops, and in comparison to normal conventional practices. So we have identified, as you see in the graph, in the medium graph on the right-hand side, we have seen biomass yields tripled or even higher yields of biomass yields when using these cropping systems that are really do not affect the traditional agriculture. For further reading now, we have deliverables that are soon to be released in our website. The deliverable 1.1 on the biogenic residues, it is a sample of which I have just presented you. And then there is an overview of the value chain 1, the biocrude oils to SAF, the value chain 2 and 3, and deliverable of on the policies overview for SAF that will be further presented by Kyriakos. They will be soon released in our website, so please follow us, stay tuned. We thank you very, very much, and I'm here for any questions you might have. Thank you.
Thanks a lot, Demasini. Thank you for your insights in the ICARUS project and the first results. And all of you, you are invited, of course, to visit the ICARUS website as well and be on tuned for the upcoming deliverables and also events. Demasini, thanks a lot for the moment. We will see each other again in the Q&A session. Just check where there were a lot of questions already. And I would like to welcome now Kyriakos Maniatis. Kyriakos, it's really nice to have you with us, not just within the ICARUS project. You will give us now a presentation that will show how at least Europeans and mission innovation countries, but also globally, can work together in this joint journey to innovative technologies for sustainable aviation fuels. Kyriakos, the floor is yours.
Thanks, Francesca. Can you see my screen? Can you see my screen? Okay, excellent. Thank you. Well, first of all, thank you very much for the introduction. Also, thanks, Mirsini, for giving the summary of the ICARUS projects. I'm very pleased to be in this webinar because for more than 20 years, I was representing the European Commission in the Executive Committee of IEA Bioenergy, and I was involved in Task 39. So that takes me back to at least 4 years ago before my retirement. However, let's go concentrate now on the presentation. The context, very briefly, I have 1 or 2 slides on global perspectives, an overview of SAF policies, more or less Mirsini message to that as one of the deliverables of the ICARUS project, and some key regional developments as I see them personally in the European Union, Brazil, Canada, China, India, UK, and US. Now, why are all of us who are discussing about SAF? And that is because, let's say, from all the sectors of the economy and even transport, SAF is the one that will continuously increase its, let's say, needs for fossil fuels. And we see that, let's say, the estimates that between, I would say now and 2050, is going to increase to almost 80%. While we see the other sectors, or the other sector of transport, shipping, has been more stabilized and costs have been significantly reduced. So it doesn't move. Right. This is a snapshot of more or less what IEA has been producing. Basically, it shows that by 2022, we have a minimal share of sustainable aviation fuels, the word biofuels. By 2030, that means in about, I would say, 5 years from now, that has to increase to almost 10%. And by then, we're going to have, of course, the very early, what we call the eSAF, that means synthetic SAF fuels from various combination with renewable electricity. And we see that by 2050 is foreseen that more or less the contribution of biofuels and the ones from the eSAF, they're going to be more than 50%. And again, we see that electricity might come to play a role. This is a clear picture. I mean, everybody knows about it. For the moment, HEFA is the SAF, I would say, fuel that is the most extensive. It is a reliable technology. The majority of the plants producing SAF at this moment, they are producing basically HEFA from used lipids, used cooking oils, fats, and oils. But the problem with HEFA is that the resource is very limited. We cannot produce so much, I would say, feedstocks with high content of oil, and the used cooking oils market is limited. So we need to develop the new technologies. And of course, very quickly, I saw again this figure that Machine showed before with the three value chains. We're looking into ICARUS. More or less, we're trying to address this issue. Now, this is a summary of the policies of the areas we're discussing. I'm not going to go through detail in that because this is going to be time consuming. Just characteristically to say, for example, there is difference about mandates and targets. The EU, Brazil, India, and the UK were working with mandates, while the other countries, they are working with targets. It makes no real reason whether it's mandates or targets, as long as the policy supporting these mandates or targets is robust. On the right-hand side, I would like to raise some comments that particular. So, for example, about the European Union, the mandate also targets the eSAF. And as far as eSAF is concerned, nuclear electricity is also included. If we go then to China, we see that actually China has no relation with STM. So they have to develop their own standards for sustainable aviation fuels. And actually, they have started the procedures to establish this, I would say, these structures within China. Secondly, we look to India and you say, and the US, what is extremely important is that they have particular emphasis on actually producing, try to maximize the feedstock development. So they take care about the feedstock. And also to some extent, Canada is doing the same with the forest they have. And from my perspective, this is a gap in the European legislation because we have very ambitious targets, we have very high targets, but there is nothing in the legislation about how to try to have new resources coming into play. And then we continue. Now we'll try to go through, I would say, the different areas we're discussing. Just in the bottom here, you will see always the name of the person from whom, in a way, I use their figures and the slides, and also with whom we have been in communication, and they're participating and collaborating with the ICARUS project. So the refuel aviation, the refuel EU aviation, it's part of the Green Deal. It is part of the sustainable transport. And basically, the policy aims to ramp up SAF deployment. Of course, all that within the European rules that they're extensive and complicated. And actually, it's a very complex legal area. But nevertheless, leave that aside. We see to the figure, the SAF is supposed to reach 2% in the next 15 months. So 2025 is going to be the end of 2025 is going to be the next 15 months, to increase gradually to 70% by 2050. And we see that the synthetic aviation fuels, or the eSAF, starts to appear by 2030 and supposed to reach 35% by 2050 of the overall total aviation fuel supply. The supply obligation is for the fuel suppliers to supply SAF blends at the EU airports. So the suppliers, they have to send the blend ready to the airport. What was interesting in the beginning of the year, that started functioning at the beginning of the year, there was cooperation between the European Commission and EASA. They issued a tender about the SAF clearinghouse. That tender was won by Ricardo, a consortium led by Ricardo, and the EU SAF clearinghouse has been created. The director is Professor Stephen Dooley from Trinity College of Dublin. So basically, since everybody knows that we have so much need for SAF, there will be new feedstocks, conversion technologies, and so on. At the same time, let's say there's enormous pressure and burden on the OMS in the US. So the idea was that this SAF clearinghouse is going to facilitate the process. And the idea is more or less that they're going to be doing exactly the same work that's going to be done in the US under the STM. They're going to be following the STM D4054, and all this information is going to be fed to the US for approval, and in the end, the standard is going to be increased. So basically, the role of the clearinghouse is to facilitate the whole process. At the same time, the UK has its own clearinghouse. I understand that China is developing its own one, and also India, there are discussions in India about it. What is important to know that non-EU organizations or companies can participate and contribute or even send samples to the EU SAF clearinghouse. Let's move to Brazil. In 2023, Brazil passed the bill 4516 that established the National Sustainable Aviation Fuel Program, which more or less will start in 2027, aiming to reduce the emissions from aviation. The targets basically will start with a minimum of 1% between 27 and 28. It will start to increase gradually by 1% every year, and the aim is to reach a commitment of 10% by 2037. In Canada, Canada has the target to produce 1 billion liters by 2030, 50% of which can be met by current and active projects. Here on the right-hand side, they issue a very interesting study looking basically to the value chains. And of course, the value chains, mostly, they are based on forestry. And this is the list of projects that for the moment they are ongoing. The ones that they are more advanced are the one in the black letters over here. The one, the green letters are actually in planning procedure. But overall, let's say for the moment, at least there are very serious, I would say, possibilities that Canada will be producing soon close to 200 million liters per year. Sorry, I have to go back. Right. What is important in Canada is that actually the government has a federal procurement program for SAF because they think that that's going to help, it's going to facilitate the deployment of SAF. And so far they foresee a budget of close to 135 million Canadian dollars between 2023 and 2031 to support SAF purchase. In China, they recently opened their technical center in Chengdu. Basically, the center is going to be trying to coordinate the industry policies, and also they try to work to have the standards. And they are going to also have SAF technical facilities. And this is the structure they have about certifying the fuels. As I said, they don't have any direct cooperation with STM, so they have to produce their own fuels. They cooperate with international organizations like IATA. We see that for sustainability issues, they have their own table of sustainable biofuels, an ISCC certification system. And basically, the China SAF Industry Alliance, they're going to feed the information they have to the various administrations. And in the end, the certificates they're going to produce. Of course, the certificates coming out and the standards out from this cooperation is going to be more or less identical with the STM certificates. For the moment, there are 3 plants of producing SAF in China. Sinopec with an annual capacity based on HEFA from used cooking oils of 100,000 tons. Ecoceres with an annual capacity, again, HEFA for 300,000 tons from, again, used cooking oils. And Henan Zhuheng Industry, that actually they have a production capacity of 10,000 tons from palm oil, meal effluent, some other waste. India is trying to develop comprehensive policies. And the government aims to give the necessary, I would say, push and thrust to the indigenous renewable sources for SAF. And of course, for that, they look very, very carefully to the local and national energy security, the environmental concerns they have, And again, as I have put in the summary of the policies, they try to boost the Indian rural development and the economy. They have mandated to start using SAF 1% by 27 to 28, 2% by 28 and 29, and to reach 5% by 2030. And on the right-hand side, you see the million metric tons of SAF from, let's say, 28 to 30, starting from 2040 and going up to 100 million metric tons. To lay down the right foundation for SAF, the government and the industry, which is very strongly related and working with the government, they have to establish a plan for certifying SAF under CORSIA. And of course, this is not only for India, but if we are going to see, we need to have global, I would say, standards. There is the need to develop SAF-related laws and regulations. They have to implement a mandatory SAF blending ratio system across the country, and they have to promote SAF use environment. And basically, for the moment, we see that it is the Indian oil companies that they are pushing forward with producing SAF. The Mangalore refinery are setting up a 40 tons per day plant with HEFA. Indian Oil has memorandum of understanding with Praj and Lazatec to develop and build alcohol-to-inject facilities with, I would say, food-based and 2G and 3G, whatever you call it, ethanol. Hindustan Petroleum is setting up 3 different plants. The first one also from UCO, the second one from Camelina Oil, and for the third one, they're still looking to alcohol-to-jet, but they still select the technology. Bharat Petroleum is also very strongly aiming to get involved, and they aim to build 3 refineries. And finally, you have a cooperation between True Alt Bioenergy and Greenco Greens, and they plan to build several commercial plants in the country. We move to the UK, and the mandate, it's still, it has been in a way decided, but it still has to become law. And basically, the mandate foresees to start in 2025, as you can see here on the right-hand side, start from 2%, increase it to 22% by 2040. They're going to have tradable SAF certificates. This is very interesting. Of course, they're going to have weighted emissions intensity, and the criteria will be to have minimum 40% greenhouse gas savings. This contradicts significantly with the European minimum greenhouse gas savings, and I think that the UK is more wiser on that than the EU, but again, this is a very personal opinion. The way they foresee is that basically they see that by 2027, 2028, the demand is going to be covered by HEFA. But after that, they see a gap. And of course, there are various technologies that they will come to play a role. But again, it's unclear how they're going to move forward and how they're going to cover this gap that we see over here appearing at about 2030 and so on. The next is US, and in the US, we have the Inflation Reduction Act. This is basically extends previous credits and introduce specific SAF credit for 24-25. It also introduces the clean fuel production credit for 25-27. And basically, this replaces existing credits. And we see also that, let's say, the credit given for SAF is much higher than the one given for just clean fuel production. And of course, they come to meet at some time later on. Then we have to notice that the US is a very big country, as we know, but not all states actually are very proactive. Of course, California was the first one to introduce the carbon fuel standard, the low carbon fuel standard in 2009. Other states have followed, but again, we see there's a big gap in the middle and also on towards the Atlantic side about states that actually have not taken any initiative. The total combined incentives ranges between $3 to $5 per gallon. One major concern the industry has is that periodically the credits are expired and then they're introduced, and that gives a kind of stability to the investors that they would like to invest, how these credits actually are moving. Of course, there are multiple LCE methodologies, and of course, that is something that has been said by several people. They need to be standardized. However, although everything sounds very possible and very nice, there are, I would say, some problems. For example, a major problem is that the US and Europe, we cannot agree on what is a sustainable aviation fuel, and that because of the sustainability criteria we have. And of course, the investors are a little bit worried about that. And that creates a kind of, a kind of uncertainty. At the same time, there is some failed investments, and this creates also, again, a problem for the investors. We see also that the purchase agreements for SAF are stalling and have been significantly reduced compared with the 2 previous years. We also see that the prices are very high still. In the bottom with the black lines, the black and gray lines are the cost of the price of kerosene, while here it is in green is the price of SAF. And we see that the price of SAF in Europe, the thicker line on the top, is a little bit more expensive than the one in the US. The bad news is that there are some, let's say, announcement that they in a way they create most uncertainty in the market. Fulcrum Bioenergy stopped the Nevada waste SAF facility. Shell announced that it had temporarily paused the construction of the big biofuel plant in Rotterdam that would also produce SAF. Also, Shell quitted the East South Swedish project, and Vattenfall cancels an offshore hydrogen project. So we see there's a lot of development, there's a lot of push, but at the same time, there are some negative things that make the investors to be worried about the situation. Now I'm coming to the conclusions. Certainly, there's significant interest and work to promote and deploy SAF with policy, market, and technology measure by all mission innovation countries. There is strong reference to develop new crops in India and USA and the US. And that, again, for me, this is something that should be looked more carefully by all countries that they're looking into SAF. There are new developments with several SAF clearing houses to accelerate and facilitate the testing of new types of SAF. But however, because of the various problems, because of the uncertainty in policies, the investors remain on the edge and they are a little bit uncertain how to invest further. With that, I would conclude my presentation and I'm happy to answer any questions there might be.
Thank you very much, Kyriakos, for this interesting insight. And what we can see that there are a lot of developments ongoing, also with some frames, with different drivers behind it. We will talk about this later on in the Q&A session as well. So thanks for the moment. Please check there are some upcoming questions that could be answered meanwhile. And let's stay a bit on the frame conditions and how can they be fulfilled for sustainable biofuels at least. And I'm quite happy to announce now Jose Mosias. She is with us in the task 39 on biofuels, and there is a quite interesting overarching project on the robustness of GHG emission certification and verifications. And Jose will give us an insight on the first results and what is the work is all about. Thank you, Jose.
Thank you for having me here. Thank you, Francisca, for your kind introduction. Yes, I would like to take you through the results so far of our IEA Task 39 project that is dedicated to the robustness of greenhouse gas emissions on certification and verification, and where we focus on current sustainable aviation fuel supply chains and policy combinations. Next slide, please. The participants of the IEA Task 39 project members are Austria, Brazil, the European Commission, Germany, the United States, and the Netherlands. And of course, also we get support from all the other members of Task 39. This study is a follow-up on an earlier Task 39 project where we had a review of several policy frameworks that is published in by Task 39 and was prepared by Jinke van Dam Consulting. One of the conclusions there was that fuel policy frameworks increasingly focus on further reducing CO2 emissions. And there are some differences between frameworks on how this should be achieved. And this leads to differences in the degree of stringency and robustness of policy frameworks for GHG emission reductions. Part 2 intends that we are working now on intends to develop a better understanding of the robustness of verification and certification of GHG emissions in biofuel supply chains. And we are now assessing current sustainability aviation fuels supply chains and policy combinations as a case study. And we are focusing on current supply chains because we want to make a comparison to how it's experienced in practice. So we are actually having interviews there. The approach that we have is the case study that consists of HEF and alcohol-to-jet biofuels, so the current supply chains, from sourcing and processing feedstocks up to blending and distribution of the biofuel. The selection of SAF-related frameworks with their underlying verification certification activities consist of the Californian Low Carbon Fuel Standard, the Implementing Regulation Act of the US, the EU RED, the Brazilian Bio, and the ICARUS framework. The assessment of SAF supply chain policy combinations is based on interactive workshops with small expert teams and desktop literature research, stakeholder consultations, so interviews, and qualitative analysis of the results. So you see at the right, the work package in the small print, so for reading purposes. Next slide, please. Yes, this picture shows the fuel flows based on expected SAF production capacity and policy-driven demand towards 2030 from the recent Sky Energy Market Outlook. In the green boxes, the selected frameworks relevant for this study, again in small print for later reference. And the two boxes at the left are the US and Brazil. They represent current nationally orientated policy frameworks. Those at the more right, that are the EU and the ICAO, they represent international cross-border frameworks. Based on the outlook, it is expected that SAF flows will interact internationally more and more, as you can see from the arrows, and also in the current nationally orientated policy frameworks. And this makes alignment between frameworks and the regulating systems more desirable. Next slide, please. To promote robustness of SAF policy frameworks, to promote the sustainability of biofuels, including SAF, policy frameworks have included GHG emission reduction requirements, amongst other sustainability criteria. And a second important element of such a policy framework is to ensure that these requirements are indeed complied with, and that there is robust evidence to prove this. Robust frameworks have a regulating system to ensure that its objectives are achieved and appropriate procedures have been followed. In the context of biofuel sustainability, verification governance plays a crucial role in shaping the robustness of biofuel policy frameworks with auditor requirements as a key component. And verification governance refers to these systems and the rules and the oversight that guide how to conduct verification of carbon intensity. Auditors are responsible for verifying the parties in the biofuel supply chain comply with the rules that are set. And we looked into several parameters that are important in such a verification process in rather quite detail, also in the first part of our project. Slide 6, please. Yes, proving compliance. Policy frameworks make use of certification or verification to prove compliance with the GHG requirements that are set in the policies. And this is simplified presentation is referring to both options. The main difference is that certification takes place before a claim, based on the evaluation of systems and procedures, and the verification is after the claim. So that's based on historical data, actually. Both options include usually independent valuation performed by an objective third-party auditor. Certification offers more flexibility to the market. So there are larger, more internationally oriented chains that are possible in these systems, but this also increases the complexity. And furthermore, in certification, it's more challenging to keep one minimum level of assurance within the framework. And the verification, in the verification, there is room for improving non-compliance is less than in certification. Next slide, please. There are several potential sensitivities in the SAF supply chain and auditing process. And sensitive in this context means difficult to verify. Those sensitivities could challenge the robustness of the system. And we made an inventory by our task members made an inventory on such supply chain sensitivities. And for this, identified main parameters affecting carbon intensity were ranked by their relevance and complexity. While reviewing the current sustainability aviation fuel supply chains, so HEF and alcohol-to-jet, it became clear that these chains are not that different from a verification certification perspective. The former speakers already showed that they are really technical different, but from verification and certification perspective, they are quite equal. At the top, you see the different chain steps, and at the bottom, potential sensitivities with respect to audit verification as experienced by the task group. So from left to right, you go through chain, and in our orange, we identified actually the most sensitive part of the supply chain. Also, yeah, we expected them turned out that they were at the beginning and at the end of this chain. If the supply chain is extended beyond the frameworks to the aircraft operator, then you have also this orange area at the right, because all the supply chains actually have their targets and mandates to set to the fuel suppliers and distributors. You can see it in the next slide, where you have the policy frame scope, the frameworks, the scope of the policy frameworks. There you can see that actually all the frameworks in the assessment, the dark green ones, are from feedstock producer up to fuel supplier. And there are other legislation, as Mr. Kyriakos Maniatis also showed, that is the EU ETS, for instance, but also in the ICARUS that is using also the sustainability framework that is in the green areas. So this EU RED and ICARUS framework for sustainability up to the fuel supplier and the blender is also used for the aircraft operator. Yes, thank you. Then the next slide. As already mentioned, an overall inventory was made by the task members on the potential sensitivities in the SAF supply chains and the auditing process. And these identified parameters were ranked to their relevance and complexity by the project members. And based on this inventory, the results were subsequently classified into 6 groups of potential sensitivities that you find below here. That are the data quality, and especially the transparency and supply chain data is important for visibility and traceability for GHG emission certification and verification. Secondly, the international policy framework differences, and especially in exchange between frameworks, such differences increase the complexity of verifying whether the final biofuels meet the requirements. And that's upcoming now because of the international supply chains that are increasing. Third, one of the orange marked ones in a former slide, the feedstock categorization, what is quite under discussion and quite a thing in Europe because of the different categorizations we have here and the valuation that is different, but also in a broader context, feedstock categorization is important because of the start of the supply chain, because in case of wastes, you have far less emissions. The supply chain starts at a later stage. The other 3 topics on the next slide that are lack of harmonization and that the need for streamlining and mutual recognition, certification, verification schemes. And also here, where policy frameworks within the SAF supply chain interact, this will create several potential sensitivities. A 5th one is auditor qualification. You can imagine requirements for auditor expertise and competence vary, and that can impact tremendously the quality of the auditing on certification verification, because the auditor is doing the risk assessment. Is furthermore the risk assessment will tell the auditor how many times it has to check a certain location, for instance. The 6th one is potential improper use, and this is something that's going on. There has been an extensive research on this for all kinds of fraudulent actions that can take place within the supply chain. So this is also a very important sensitivity. Next slide, please. The next steps that we are now preparing is the validation of the collected sensitivities, and then with stakeholders in practice, and we are preparing these interviews now at the moment. After that, we are planning to do a benchmarking of the GHG mitigation potential and determine the implications of sensitivities in verification and certification approaches, and that we do qualitatively. And furthermore, the final report is expected to be at the end of the year. Happy to take any questions afterwards. Next slide, please. There you can see all the people helping me with preparing this task and this project. Thank you very much for your attention.
Thank you, Jose, for giving us this insight to this interesting project, which is, if I may add, completing several other studies that have been made on approaches for GHG emissions, but also in combination with SAF technology tasks that are elaborated within the IEA Bioenergy. Thanks a lot for the moment. And some of you may recognize that there were a lot of quite interesting questions in our Q&A framework. And I would like to invite Mercini, Kyriakos, Jose to come to me on the panel, on our virtual panel. So yeah, there were quite nice questions. At least Mercini and Kyriakos were quite efficient answering some of them. But let's start a bit on the discussion that we have here today. So we have the idea what we will going on and elaborating in the ICARUS project, which is on dedicated technologies, on future innovative technologies. We had, Mercini, I will start with you. We had a lot of questions with regard to the biomass, of course, because biomass is the key to end up with to sustainable biofuels. And there were questions about how we move forward, not just from the European side, but from the global side with lignocellulosic biomasses, also with regard to reducing production costs, as we will then discuss that, of course, costs and availability of sustainable biomass is a key to produce SAF by the end in a competitive way. Mercini, can you please elaborate a bit on that? Maybe also reflecting on the questions that you already answered. Thank you.
Thank you very much, Franziska. I tried to reply as best as I could because I was the first presenter, so I had plenty of time. There's the very same question always: is there enough biomass to cover all these uses, not only energy, but recently we have also bioproducts. And then about costs, is it cost effective or not? Well, there is not any silver bullet option. It all depends on the demand. If the demand is higher, I'm pretty sure that there will be more ways to use this underutilized biomass, and it will be done in a cost-effective way. What we have identified so far is that there is enough biomass that is not used for feed, at least, that could support SAF production, but also advanced biofuels in general. It always depends on the logistics, how to better organize it, how to collect it when in cases that it is difficult to be collected, like the planning, for instance, how to transport it and how to finally use it. But there are, I'm pretty sure there are ways to make it in an economical way. Apart from the residual streams, there is a new biomass that can be produced as the new crops are presented and the cropping rotation systems. There are many systems, as I showed you. I didn't go into details, meaning that those cropping systems could be adjusted to a number of geographical locations and climates and issues, not only in Europe, but also globally. So we are very happy to always include part of our studies, in our studies, this new low TRL still feedstocks and low TRL cropping systems that could be adjusted elsewhere. In ICARUS, we have the pleasure to work with India, and we will have an exchange of sorghum varieties and the way of cropping systems information in our countries to check how it grows and so on. We couldn't do it for Brazil. It was a matter of finding partners, but really we are very willing to work with colleagues. We are open even for the participant of this webinar to contact me. You can see my email in the presentation. So we are open to discuss about with them what are their data and how we can collaborate perhaps in the future. So it always depends on the demand, and I'm pretty sure that biomass will be there. I'm not sure if I covered the whole of it.
Yeah, perfect, Mercini. What do you see for the future? So decreasing costs for the new biomasses that are not that much in use yet, especially the lignocellulosic ones. This is something where we often see learning curves and that stuff.
Yes.
But of course, it's a matter of demanding from the market, right? So if the demand is rising, and this would be the case with increasing capacities, not just for SAF, also for other renewable or bioeconomy reasons, could you please elaborate a bit on that? And then
it's exactly what you say. It is the learning curve. Exactly as the technologies have proceeded, and now they are really we can see that the production cost in the technology itself is being decreased all the time. That will be the case also for at least for the new cropping systems that we are talking about, and for the logistics. It all depends on really on the demand and how urgent will be to use this underutilized biomass. So yeah, more or less.
Kyriakos raised his hand, so I guess it's for the biomass as well. Please.
You are muted.
You are muted. So please, you need to open your micro.
Yeah. Okay. Sorry. I fully agree with what Mr. has been saying. But any kind of biomass from agricultural resources or forestry resources is going to be expensive. Of course, this will cover everything, whether it's going to be used for SAF, power, or any other biofuel. That's why there is, at least on some, there's quite some interest for the municipal solid waste. Of course, all sorts of municipal solid waste. And for that, we have the gasification to fusel trough technology that actually can most easily use, I would say, municipal solid waste. And of course, we see that most of the projects working on gasification of biomass and fusel troughs, they're trying to go for this resource. Why? Because the one that either has a negative cost or a cheap cost. For the rest, what was one of the questions raised during the discussion, it is extremely important that for every, I would say, every plant, that they secure a long-term stable supply chain, starting from the piece of land where the resource will be cultivated, or the forest, till up to the, I would say, to the storage of the biomass into the plant. And unless this is long-term and stable, things are not going to work very easily. We're always going to have problems on the supply chain. So it's very critical to have a stable, reliable supply chain for any kind of application.
Fully agree. Thank you.
Now it's me with the micro, sorry for that. This is really a huge issue. We also saw queries in the Q&A which are dealing with the pressure on used cooking oil, for instance. So we have most of the capacities elaborating at the moment are based on these residues. So yeah, there is also an impact, of course, to different rural areas and developing countries in that regard. Kyriakos, could you please elaborate a bit on that issue? How do you see the way that we, or what are the needs within the frameworks that you showed, presented us from the different countries? Which of the regions might be the first ones who come up with the new technologies in addition to these HEFA based on UCO? What do you think? So they have different conditions, right, to start with?
Yeah. The US, of course, Europe, and also India, they're extremely, how can I say, they're progressing extremely fast with new technologies. They're, for example, it's particularly in India, they're building at this moment plants for alcohol to jet. This is not so much in a way, how can I say, it's not so much interesting in the EU. Why? Because all the facilities we have in the EU, they stopped operating. The last one was Clariant last year. So alcohol to jet, in a way, I don't see taking off in the European Union. We might be importing alcohol to jet SAF from elsewhere, but I don't see it developed in Europe for various issues. Certainly the US, in the future Brazil, because of course in Brazil they have the sugar cane and the sugar, so from it will be very easy to actually go along the line of alcohol to jet. For this, what is very interesting, and that goes to the resources, it will be to develop, rather I would say cheaply and big scale, resources with high content of lipids. Algae has been discussed a lot, but the algae content of lipids is very small and it's not really useful. Jatropha was discussed a lot 10, 15 years ago, but it doesn't really work because you cannot put it in marginal lands and so on. So the main emphasis of the sector remains to be used cooking oils. There was some activity from UPM in Uruguay to produce, wasn't Camelina Messini? Help me?
Carinata?
Carinata, yes. Carinata, that worked very well. But again, now somehow we don't know how, let's say, UPM is going to develop. So we need significant efforts because the cheapest value chain is oil, hydrogenated vegetable oils, and then the sulfur. And we need for that cheap oils or used cooking oils. All the other resources, they are based on, I would say, biomass resources. And from this, perhaps the closest to the market is alcohol to jet. Gasification to future tropes needs still to go through, I would say, at least 1 or 2 more large-scale plants being built and run operationally. Opening parentheses, with alcohol to jet, Lanzarote has been very successful because they can also use, let's say, gases that they are not coming out from biomass to produce ethanol. From the ethanol, you go to alcohol to jet. And this type are also covered by the European legislation. So that, again, is going to move rather fast because the resource is there available as a waste gas from steel mills and so on.
But this depends. Yeah,
Uh,
especially for the European Union. So we need to check a bit on the frame conditions set at the moment for the refuel aviation on RED to go this way like Lanzarote do in Asia, right? So with the steel gases and that stuff. Kyriakos, Jose, I have a question to you both, which is of course connected to the technologies, but at least also to the certification and harmonization issues for carbon accounting. I will just repeat. In 2027, it seems to be a date by which certification and harmonization of carbon accounting may need to be in effect in the several policies and to meet country mandates. So we have these increasing mandates in different regions. Can we expect to have the financial financial hurdles to revert? Oh, sorry, I did it wrong. To revert when this is in place. So the overall question is, do we have favorable policy and economical scenarios available by 2027? So it's just in more or less 2 years. Kyriakos, will you start and then Jose?
Yes and no. I mean, it depends how you see it. The European Union will have the Refuel-EU Aviation, which is very straightforward, very strict. At the same time, the requirements from greenhouse gas emissions reduction, they're rather high. They're going 60–70%. We saw that the UK and the US, they are much lower. And this limits the availability of resources that can be used to produce SAF or any other of advanced biofuel, but let's stick with SAF. So yes, we have the resources. Yes, we have the policy in the EU, but I think that somehow it needs to become a little bit more flexible. There's another problem with the policy in the EU that often they are changing. Every 3 or 4 years, there's a change in the EU policy, whether it's the REDs. I hope that the Refuel-EU Aviation will stay stable and not going to be modified within 2 or 3 years. So within Europe, I would say yes. The US also, I see they will have the possibility because the US system is very, very flexible. And then if I look to India and China, they're also very flexible. And I think that we will have the way of doing it. We will have the resources of doing it, let's say, and the political framework is there to facilitate this kind of, let's say, moving along the changes in standardization or issues or this kind of topics.
Okay, thank you. Jose.
Yes, thank you. Well, actually, with certification harmonization of carbon accounting in place in 2 years, I think that's a very, very short time. Because when you look at Europe and the situation of the UDB, it takes really a long time to have all these accounting rules in a system that is confident, that everybody is confident about that it will work. So I think to be realistic, I think in 2 years it will be a very quick period. It's too short. but we can move forward to it, of course. But but if it will be in place completely, I adopt it.
Francesca, were you asking about the international environment or country or region by region?
Yeah, I guess it's of course a challenge for as Jose mentioned, maybe for the European Union, but it's of course it's connected with the UDB. This is for all the participants here. We have in Europe a union database where all the biofuel or renewable fuel supplier need to handle their data to be transparent for the certification schemes. But we have also on the other hand side, policy instruments like COSIA and in parallel, of course, the certification schemes that are already in place. So
Yeah,
to my understanding.
Yes,
yeah.
sorry, but because I saw it's a question from Brazil, I saw, and so I think it's a manual question. So I think if you look at how long it takes for even a smaller part of the world to get it all harmonized, then I think for having a complete set of rules in place in 2 years, that will really be a challenge.
Yeah.
I fully agree. I don't see it coming. I would even say within the next decade, because I don't see the European Union changing its policy. And I don't see it will be very, very difficult for the US to change also their policy. So, and of course, these are I would say, the two major economies that more or less they can lead technically on the stance, with all the respect, of course, to Brazil, India, China, Canada, and so on. But I don't see easily to have the change of the European Union towards at least, let's say, palm oil. And the issue is what happens. And I've been asking this question, I don't know the answer. If a plane leaves from Europe, lands in, let's say, Jakarta, then loads up SAF produced from palm oil and so on and flies back to Europe, is that going to be accepted? And this is a question that for the moment, nobody can answer it. And it creates a big problem on the international, I would say, system, which also keep the investors, because people, they're afraid to invest in certain areas because of exactly the different policies, whether, let's say, it is Europe, US, Canada, or so on.
What do you all think about, there's also a question on that, waste to SAF. So we have this recycled carbon fuel issue in Europe. Kyriakos, you mentioned, of course, the municipal waste projects ongoing or more or less hindering a bit, especially in the US and in Canada. We have nice examples there. How do you see the perspective on waste to SAF as an option for SAF maybe in a short term or in a medium term? Might this be faster because we have, in parallel to the renewable energy issues, we have a lot of recycling targets and strategies in different areas of the world. So this is a topic in parallel. How do you see that?
If I may again start, the problem we still face that we still need at least to have one facility via fissiotrops, gasification of waste to fissiotrops, and then to operate for about, let's say, 1 or 2 years without any major problems. In the past, there have been some examples. In the past, it was for other reasons they faced. For the moment, there are just 1 or 2 activities that they are going on. And unless they will come on stream and will be successful, then indeed, it might be a problem for an investor to invest in these technologies that they still might think that they're really, I can say, not fully technically reliable.
Yeah.
So if that will come through, if we're really going to have successful technologies operate on the commercial level, then this is going to be a major breakthrough, because then you avoid all the problems of the biomass availability. Waste is always going to be there. Okay, we need recycling, but there's always going to be waste, whether it's from industry or from municipal waste, that could be used to produce, I would say, SAF via gasification fissiotrops.
Jose, how do you see this point on the compliance issue of certification and verification? And of course, it's also a bit connected with the task producing a waste, right? You are muted. Jose, you are muted.
Sorry. I think it's it's difficult then also to have a right accounting, a way of accounting the benefits of using that feedstock. There are already, at the moment, there are already differences. If I'm right, ICARUS also has a bonus, I think, for using the waste. And in Europe, there is still some discussion about how to account for that, for the emissions in the right way. So I think it's also for a perspective of harmonization, it will be also here, it will be quite a challenge to have a right way of accounting this kind of feedstock. And then I'm looking at the system, not at the technology at all, but I'm looking at the other side. So that will also be, a challenge.
Okay, thank you. Luciani, there's a question to the ICARUS project and the chain 1, which is on the bio-oil to SAF. Yeah. So there's a question on, is there a standard for bio-oil which is intended to be used in the SAF pathway, especially for the hydrotreating or not? And maybe reflect on that or combine with another question. Which come up with here some rural areas in the rainforest. So I guess it's about the story that we have, of course, rural areas and the competition with huge agricultural areas and producers. So how they can compete, but also could support new routes or new technologies also with their feedstock.
Now, regarding the first question, I'm not the perfect person to respond. However, there is in the deliverables I cited in my presentation, there is an overview on the value chain 1 on the biocrudes. And there, if I'm not mistaken, there are standards that will be taken, the existing standards that will be taken into account for our research. I'm pretty sure, please contact me by email and I will pass the question to the leader of this value chain, which is Francisco Girio. I'm not sure if he attends also this webinar. If so, then perhaps he's the best person to respond on that. However, I will try to check and I can come back by email. Now, regarding this issue with the rainforest and the marginal lands and things, there are sustainability criteria defining in which areas we have access to produce whatever it is about. So, by fulfilling these sustainability criteria, then we can know which kind of marginal lands we can access and what kind of crops adapted to these soil conditions and the climate conditions we can use for producing SAF. I believe that there is still research going on. No, I believe, I'm sure. There is still research going on regarding the best crops to also use in this kind of areas so as not to exhaust the marginal areas, because we are talking about arid conditions. Everything is under discussion. Everything is under research at that very moment.
Okay, thank you, Marcini. On that regard, I guess it's also a bit about having more or less standardized intermediates, yeah, biocrudes, bio-oils. So because we know there are quite different qualities, depending, of course, on the feedstock itself, but also on the processing. For instance, hydrothermal liquefaction or pyrolysis and that stuff. There were also questions in that regard. We have some few minutes left, and I would like to open a bit, despite we all are quite familiar and famous with the biofuels, we have an international ongoing or increasingly discussion also on these power-to-X products and e-fuels. And this is heavily connected to aspects on carbon capture and use or carbon capture and storage. So we have the link to the BECCS, bioenergy carbon capture and usage of storage, but also with the e-fuels. There are also several projects ongoing on this. Especially in Europe, we decided to separate a bit the story from biofuels and the e-fuels. So the renewable fuels of non-biological origin. Could you please reflect a bit on that? Kyriakos may start from an international perspective, because we know also from other IEA advanced motor fuel tasks that this is heavily different reflected what are e-fuels and how, and this is a huge synergy topic to be raised maybe here as well a bit, to combine these different technologies and be on the end supplying SAF, for instance, as this is a topic of today in such combined systems. Kyriakos, how is this reflected in your international studies?
Well, everybody's talking about ESAF because, of course, it's the next fruit, but it's not a low-hanging fruit. So always we try to go for the low-hanging fruit, but of course, everybody dreams to go for what we think is the better fruit, which might be higher up. Now, certainly it will come. Certainly there are different perspectives in the different countries, but the question is, for example, how we're going to be organized everywhere, even in the countries, for example, even in the Arab countries, because they have the sun. They're also over there. They're looking to producing stuff from, let's say, solar energy, producing renewable electricity, convert it into SAF and export to Europe or anywhere else. I don't see that as a problem in terms of technology production. I see that as a problem indeed how we're going to account about the carbon. And on the long term, I'm a little bit concerned about Europe because we know that Europe, we cannot produce enough renewable electricity to our needs to decarbonize, to defossilize, I would say, the power sector, for example. And we're going to be, they're also, extremely better than me. There are plans from German companies to produce it in Latin America or in Africa and export to Europe. So this is really a kind of, how can I say, it makes me have uncertainties how far it's going to be materialized. Certainly within the next 2 years, we're going to have the first plants producing, but they're going to be like the small plants. They're going to be, the stuff coming out is going to be terribly expensive. It's going to be even more expensive than the one coming out from the biomass, but for the biofuels. And of course, there's a lot of discussion how we get the hydrogen. If it's hydrogen from renewables, no problem. But if it's hydrogen from natural gas, or blue hydrogen or gray hydrogen, whatever it might be, then it creates another very big discussion. And of course, what do you do with all the carbon that you separate and all this kind of thing? So yes, we're going to have ESAF. In different areas of the world, there are going to be different, I would say, policies supported, and different exceptions. And then the problem is how that can be used, let's say, in an economy like the European or in the US or somewhere else. So a confusing view, if I may say so.
Yeah. To my understanding, there's also a great chance to see these technology both, because there were also another question when we are talking about syngas routes to SAF. This is typical thermochemical, and these are the same technologies for the Fischer-Tropsch route and the methanol to or alcohol to jet. So it's just that the way to the syngas is a different one. And I clearly see, because we have heavily discussions with that, especially in Germany as well, that we have the chance to rethink a bit also the role of biomass, right? So it's not just the biomass as an energy carrier for the future, it's also reflecting on the biomass as a carbon source, because e-fuels or e-products are nothing without this carbon source. Jose, what do you think about moving forward also to go for combined hybrid systems that are considering the bio-based part and the e-SAF part for these certification verifications? We have, at least in Europe, but I guess it's reflected in another way in the other countries. We have two strict different approaches to reflect on the GHG emissions and on the sustainability issues. What do you see for the future, how we can harmonize this in a way that is less complex and allow to move forward also with the technologies? What do you think?
harmonizing e-fuels and bio by their calculations. Well, yes, I think myself and our group also is more into that e-fuels is more, well, it's more cost effective to not to produce it in countries where there is a lack of space. So, well, I think Europe is not the most ideal location for actually producing e-fuels. So I'm not sure if that's at least partly answers your question, and it's maybe not what you like to hear, but well, I don't think it's a good thing to put too much pressure just to produce this fuel at locations that actually are not ideal, and there are much more locations further on that are best prepared for this.
Yeah. So looking on the time, thank you. We have much more questions. Thank you for the discussion, your presentation. So we have seen that ICARUS is starting. There's a lot of ongoing on the international way to the journey to develop technologies to be sustainable and to maybe be part of these 10 times more renewables that we need at least for 2050. This is enormous and needs all our efforts. And thank you to the participants for, of course, participating, but also for this many nice questions and notices. So they are all well recognized. This keeps me to invite you, because all is ongoing, to our next workshop. And this workshop will be happen so it's in the next slide, please, in Sao Paulo, together with the BBEST and the IEA Bioenergy end of triennium conference. Be all invited. We have a nice ICARUS both workshop with presentations, but also panelist discussions in that regard, so we can follow up what we started discussing here today. And then this is end of October, and then do not need to wait so long. 10th of October, we will have a webinar also here from the IEA Bioenergy Task 39, together with Susan van Dijk and Jack Sadler, who will elaborate much more on the SAF technologies, where we stand for the moment, what is to do in the future. So please join this webinar as well. Merci, Jose Riacos, but also thanks to the ETA team and to the Task 39 supporting this webinar. It was a pleasure with you. I hope you enjoyed it as well. And yeah, have a nice evening, a nice day to all, and hope to see you soon in Sao Paulo or even for the next webinar. Thanks a lot. Bye-bye.
Thank you, Francesca, for all the support and moderating the discussion. And also to all the participants. It was very good. Thank you.
And
Thank you.
many
Bye-bye.
thanks for all the questions, and there were a lot. Goodbye.
Thank you. Bye-bye.
Bye.